When you create a sample, the next step would be to find the point estimate. And when you create a different sample, you'll get a point estimate. You do another sample, you get a point estimate. And generally, every time you do a sample, you find a point estimate. And oftentimes, those point estimates are going to be different, even if you do the exact same steps. So, in general, point estimates will vary from sample to sample. And we quantify this variability in what is called the standard error. So, essentially, the standard error is equal to the standard deviation associated with that point estimate. So as far as abbreviations go, when I'm using the term, when I'm using SD or standard deviation, that's the standard deviation you've been using this quarter so far. That's the standard deviation of an observation. SE is the standard deviation of a point estimate. That's the amount of variability you can expect when you do some kind of experiment or some kind of sampling over and over and over again. So kind of illustrate this, consider rolling dice. Now, a single die roll is equal to is equally likely to be 1, 2, 3, 4, 5, or 6. The standard deviation will reflect that result that it could be anywhere between 1 and 6. So the standard deviation is going to be fairly large, or relatively large. And you see it in this graph. Oops. You see the graph at the top here. There you go. And that all the bars are more or less equally likely, and so things are going to be fairly spread out. Now, if you roll like 10 dice and find the average, roll 10 dice and find the average, roll 10 dice and find the average, you get something that's that looks fairly normal, unimodal symmetric, but it's a little bit tighter now than the original distribution. All the values are generally between 3 and 4, or most of them are between 3 and 4, not too much outside that. If you roll 100 dice and find the average, and another 100 and find the average, another 100 and find the average, and do it over again, you're almost certain to have an average between 3 and 4. So there's relatively very little variation by the time you do samples of 100 dice. We'd expect the average to be pretty much around 3.5. So the standard deviation of these samples, called the standard error, will be much smaller in the 100 dice than it would be the 10 dice, or even from the original sample of 100. You can see that the bottom graph there, everything's very tight, very little error, or very little deviation. The way we calculate the standard errors will vary from one situation to the next, and we'll get to that in later lessons. Generally, it is determined using a formula based on the central limit theorem. Anyway, for right now, I'll just give you the standard error. There'll be formulas in later lessons, but for right now, it'll just be given to you.